all this like accessory electrical tape you find all over the place, this is the #1 DIY mistake. Hey, this is Electric Pro Academy. I am Joel Walsman of Jefferson Electric, CEO and Master Electrician. Today we're going to explore wire types, some terminology around wire, and basic wire connectors. This is a vast discussion that we're going to take at a first pass entry level. Here it is. There are 3 terms that are used to describe wire size. Here before me I've got about 10, 12 different sizes of wire. The first of those terms would be gauge. What is wire gauge? Well, typically it's like shotguns, right? The larger the number, the smaller the shell. The smaller the number, the larger the shell. Gauge corresponds to that. This is a 14 gauge conductor. For comparison, so this is 14 gauge, this is 4 gauge. The smaller the number, the larger the wire. Gauge measures wire from 4/0, which is the largest of the gauges, all the way through very, very small gauges, like this Cat5, which is 24 gauge. However, with respect to building wiring, power wiring in buildings, 14 is going to be the smallest that we'll explore today. This is a Romex, or non-metallic cable. It's a 3-conductor, 14 gauge. Black is hot, white is neutral, copper is ground, bare is ground. These are all 3 copper conductors. This 14 gauge Romex, or non-metallic cable, is equipped with 1 hot conductor, 1 neutral conductor, and 1 grounding conductor. You'll actually see that this is packaged and referred to as 14-2. The ground is not included because under normal circumstances, it is not a current carrying conductor. So that's 2 conductors plus ground. What a 14 gauge non-metallic cable, or Romex, is typically used for would be your standard branch circuits, like lights, switches, and receptacle outlets in living rooms and bedrooms. This is the basic backbone of your wiring infrastructure. Its slightly larger older brother would be the 12-3 Romex wire. And there's 12-2 as well, but my demonstration includes a 12-3, and that's a black for hot, a red for a second hot, a white for neutral, and a bare ground. So this is a 12-3. What 12-3 or 12 gauge Romex would typically be used for would be slightly higher power receptacle outlets, like dedicated runs to the laundry room, kitchen, maybe the garage, exterior outlets, things that are anticipated to carry a slightly heavier load. Typically in a home, a 14 gauge wire is going to be connected to a 15 amp breaker. A 12 gauge wire is going to be connected to a 20 amp breaker. Next we have the 10 gauge, and you'll notice there is a systematic color coding going on here. But just be aware, if you're in an older building, like 1970s or earlier, you're not going to find this color coding going on. It's not going to be consistent. So you're going to have to pay attention to the labeling on the jacket to determine the gauge of the wire if you don't have something available that will provide the gauge for you. So this 10-3 Romex would be typical of like a dryer, power to a dryer. 10 gauge Romex in particular could be utilized for a heater in the garage. Not a whole house heater, but just a space, fixed in place type of heater. An air conditioner, an electric vehicle charger, things of that nature. Now this would be a lower powered electric vehicle charger. We have 8 gauge wire. This 8 gauge Romex wire is useful for higher powered air conditioners that service larger homes. Is also useful for cooktops and electric vehicle chargers. This is an 8-2, so 2 current carrying conductors with a ground. You have your 8-2, your 6-3. Here I've got a 6-3 Romex. Now this is a larger gauge, as you can tell, and it contains 3 current carrying conductors plus a ground. This would be for like an electric furnace, a full rate Tesla level 2 EV charger. This is going to be a higher ampacity wire, a double oven in a kitchen, an all-electric range or cooktop. But we also have other types of single-strand conductors. These are referred to as THHN. It's the wire designation. The T, H, H, and N all refer to characteristics of the wire that communicate its proper use and its ratings and characteristics. We're not going to go into that at the surface level just yet. But this single-strand wire that does not contain an overall outer jacket is not intended for run in free air. It must be protected by an external conduit, whether that's a rigid conduit, a flexible conduit, a PVC conduit, a metallic conduit, whatever the case may be, this single-strand wiring must be protected. Here we have a 12 gauge, we have 8 gauge, we have 6 gauge, and we have 4 gauge. This is a 4 gauge THHN copper conductor that would typically be run as one of multiple conductors in the circuit. So you can tell the sizes are getting larger. We've got 4, 3, 2, 1, and then when we cross over into the larger sizes of wire, we get into the aughts, 1/0, 2/0. These are increasing in size, 3/0. Here I have a 4/0 aluminum conductor. If you look really closely at the end of this wire, you'll see that there are no voids between the conductors. So this is actually a compact 4/0 aluminum conductor. The fact that it's compact allows more of these to be combined into a smaller space while maintaining code compliance. So this is a 4/0 THHN aluminum conductor. We've got various colors. All of these THHN conductors come in a host of colors, each of which is intended to provide differentiation and voltage identification for a circuit. Up here we have the 750 MCM or Kcmil conductor. This is an extremely large conductor. Something like the 4/0 conductor would be utilized to bring 200 amp power to a house. We're up into a 500 MCM or Kcmil conductor, and I'll explain in a minute what that means. That would be like to bring power to a restaurant. But this 750 Kcmil, when combined with other conductors, would be utilized to bring power to a small apartment complex or something really significant. Now, what do I mean by Kcmil and MCM? See, the old term is MCM, and when you talk to the old guys, they're still going to use that term, but the newer code term is Kcmil. But ultimately, they refer to the exact same thing. There's just been an update. See, the MCM refers to thousands of circular millimeters. Kcmil refers to kilo circular millimeters. So it's a metric designator to describe the physical area of the wire. And that's the difference between the term MCM, which is from the old times, and Kcmil, which is the present code vernacular. All right, so to further expand for people entering the trade, you're going to be primarily concerned with these 3 types of wire in residential wiring and construction. Your 10 gauge for moderate appliances, air conditioners, dryers, small space heaters. Your 12 gauge as defined by code for small appliance branch circuits to kitchens, baths, laundry rooms, and similar spaces. But your 14 gauge, this is your everyday guy. This one's going to be all over the house. I also want to illuminate that there are dozens and dozens and dozens of other wire types for other applications, but these would be the dominant residential wiring types. These would be for power distribution systems. Single strand would be contained within conduit systems, and Romex would be run independently. Now, what's my gray guy here? All right, now this is UF cable. UF cable contains a molded jacket. The molded jacket contains individual conductors. I've already started to slice this open here. It's a heavier lift to open up a UF cable. And what I've got is the molded jacket firmly around each and every conductor. So I've got the same thing as my Romex, but this overall jacket is rated for direct burial in the earth. These jackets are not. Romex is not. This UF cable is rated for direct exposure to sunlight. It will not deteriorate in UV or exposed to water. So this is interior wiring only and is not suitable for a host of other wiring applications. I also want to introduce you to a variety of types of wiring connectors. Again, there are dozens, hundreds of types of wiring connectors, but these are going to be the basic types that you'll probably find in a residential construction site. We have our typical wing nuts, which come in a variety of sizes and distinct color coding. This yellow wing nut is perfect for two 14-gauge conductors. This tan wing nut, ideal for two 12-gauge conductors. Red, maybe 3 or 4 12-gauge conductors. Get into the larger sizes, and now you're probably joining 10, 8, and 6-gauge conductors together. It's important that the wing nuts are sized appropriately to get a tight, safe connection, but too tight, and this plastic wing nut actually starts to bulge and could encounter failure. So what you'll find is the manufacturer has specified the type and number and size, both minimum and maximums, that these wing nuts are suitable for. It's important to respect that. Moving on, we actually have an interesting type of wing nut. This is a direct burial rated. Now, I wouldn't recommend making underground wiring connections in direct contact with the earth, but if a repair is needed underground, these would be the ideal wire types. They actually they're single use, and they contain a jelly-like substance which will promote electrical conductivity and prevent the intrusion of water. In the case of smaller conductors, like data and communications, there actually is this little device called a Scotch lock or a jelly. This jelly, and each jelly, is rated for a certain number of conductors. In this case, 2 conductors can be admitted to this jelly, 1 conductor in each wiring slot. The jelly is compressed and pierces the outer jacket of this 24-gauge Cat 5. Now that's distinct from building wiring, which typically requires being stripped, a solid pre-twist, and we're going to show you this again and again in later videos, because one of the top responsibilities of an electrician is not only to size his wire appropriately, but also to make excellent wiring connections. So the 2 conductors have been pre-twisted, the appropriately sized wing nut has been selected, and twisting on to the right until a firm connection is made, and you'll actually get a sense for that. It's about 8 half twists or 4 full revolutions to make a tight wiring connection, and the tug test is always recommended. Moving on, we also have obvious wiring terminations that you're familiar with. This would be a single pole 15 amp breaker and a 2-pole 30 amp breaker. These are both Siemens plug-on breakers, very standard and typical for residential or even light commercial wiring. And you'll see that the wiring connection is a stud, a terminal stud at each of those ports. Progressing to other types of wiring connections, this would be a 4-terminal or 4-port Polaris lug. These caps are installed to prevent accidental contact with the live terminal. And what you'll do is insert the wire into the Polaris lug. After loosening and opening the lug, using a torque wrench, one will be able to obtain the proper torque according to the rating of the lug. And it's also important to note, just like our wing nuts, these lugs are rated for a minimum and maximum wire size, 1 conductor per terminal, and in this case we'll join up to 4 separate conductors into 1 common termination. Polaris lugs come in a variety of shapes and sizes. Here we have a larger and a smaller. The smaller is rated from 4 to 14 gauge copper or aluminum conductors, and the larger is rated for 250 MCM, which is how this is designated. Remember, that's equal to Kcmil, all the way down to 6 gauge. Again, copper or aluminum. Now that's an advantage and a distinction of the Polaris lug that is not shared by copper split bolts or wing nuts. These devices, terminal devices, are only rated for copper conductors. It would be a code violation to terminate aluminum conductors under these devices. And that's in part because the combination of dissimilar metals is going to cause corrosion. Anytime you combine copper and aluminum in an environment where certain measures and precautions are not taken into consideration, you're going to have corrosion. You're going to have separate expansion and contraction coefficients between those dissimilar metals. And not only does corrosion create resistance, and resistance creates heat, but the expansion and contraction. Let me give you an example. If I were to combine a 10 gauge copper and a 10 gauge aluminum conductor inside this wing nut, I would be creating the right environment for fire. I would be creating a corrosive environment where the conductors could quite literally, because of the expansion and contraction due to current flow, which means heat, work themselves loose from each other or the wing nut. And so I'm creating a high resistance capacity environment. So to overcome that, this is the preferred component. This is called an AlumiConn. An AlumiConn is a proprietary product. This is a 3-port. It's similar to a Polaris lug in concept, but this AlumiConn is specifically rated, listed, and tested for small branch circuit aluminum conductors. Each port can be utilized for either copper or aluminum, but 2 conductors cannot be combined in 1 port or terminal. So this AlumiConn is rated for 1, 2, or 3 total conductors to be terminated in this device. There are other aluminum rated devices, but they do not have a permanent status and are considered temporary only. An additional type of wiring connector is the butt splice. The butt splice, just like anything else, has a distinct set of ratings. So don't throw away your packaging, hang on to it, pay attention to the ratings and suitability of each wire connector. The wire is inserted into the butt splice. Diagonal crimping pliers are then utilized to crimp down the appropriate side of the butt splice. This is a good thing those are high leverage. That was a bit of a lift. And then inserted into the other side of the butt splice would be the second wire. And that corresponding side would then be crimped to create a complete wiring connection. Now it's important to note that this would not be a safe or typical wiring connection until contained within an electrical enclosure, like a junction box. An additional type of wiring termination would be a terminal block. This terminal block is a neat way to bring together multiple wiring connections in a safe, concise format. Now this DIN rail to which the terminals are connected would be mounted inside an electrical enclosure, and then wire would be brought in one side, terminated, and would have a direct pass-through 1-to-1 ratio or relationship with wiring exiting the other side. It's a good place to bring together 2 wiring systems. It's a good place to conduct testing. It's a concise format for wiring connections. This is not typically found in a residential environment, although we do use these type of terminal blocks in our Solidex for rooftop photovoltaics, and that would be found in a residence. These big guys, these big lugs of copper, these are called split bolts. A split bolt is literally a bolt with a split in it. And split bolts are utilized to combine 2 conductors. Now, I'm not going to actually show you the full wiring connection here, what I would do is take 2 pairs of channel locks, snug this down like it's no tomorrow, and then wrap this entire, because obviously this is uninsulated and exposed right now, and wiring terminations need to be insulated. So I would wrap the entire split bolts in rubber splicing tape, probably a total of 3 comprehensive wraps. And then on the outside of that, would use Scotch Super 88 and wrap that about 3 more times to complete a sound wiring connection. Now, a couple things here. One is this split bolt, this copper split bolt, is not rated for aluminum wire. That's violation number 1. Consideration number 2 is I often find these split bolts being utilized by unlicensed electricians. I'm talking about handymen who are upgrading electrical services at a home and utilize a device like this to make an outdoor wiring connection between the customer premises wiring and the utility service drop. A couple reasons that's not a good idea. 1, this is not an outdoor rated device. It's really important to note. Water will infiltrate electrical tape. Electrical tape is not a waterproof or permanent outdoor solution. So what I find is customers call and report, hey, my lights are flickering. I'm having trouble throughout my entire house. We'll roll out there, and if the symptoms have been indicated throughout the entire house, we'll go straight to the electrical service. And man, I tell you, 3, 4, 5 times out of 10, somebody has upgraded the electrical service in times past and has utilized a cheap, quick, inexpensive, common item like a split bolt to make an outdoor wiring connection where there's not proper waterproofing, or maybe a copper split bolt is used to connect aluminum wiring, and we've got the whole dissimilar metals issue, and now the entire house is acting up and at risk of fire, arc flash, explosion, failure. See our other video on how that went dramatically wrong for me one time, thankfully through no fault of my own. Don't cut corners by making utility connections yourself. If you're a licensed electrician, you'll pull a permit, you'll coordinate with the utility, and they'll be responsible for making the exterior connections with the potential of weathering, dissimilar metals, all of those contingencies. They'll make those connections with a hydraulic crimp, again, jelly-filled substance to displace water and create and maintain a watertight conductive environment. This is not the solution. Okay, so in the context of everything that I'm sharing with you right here, and how you have to select the right wire for the right conditions, how the right terminals need to be connected and associated with the right wires, the right methods need to be utilized to secure the terminals and to properly waterproof them. You've got to consider dissimilar metal types. You've got to consider minimum and maximum ratings. Like, all of this has to be taken into account, but sometimes it's not. I'm going to share with you 2 violations that I see all the time. Number 2, lamp cord. Lamp cord. Lamp cord is not building wiring. Lamp cord is rated for nothing but to go from the lamp to the plug. That's it. I see lamp cord being used in place of 12 and 14 gauge wire. Lamp cord sometimes, at best, is only 16 gauge. It is not rated to be a branch circuit conductor. It's undersized. It's underpowered. The likelihood of failure utilizing lamp cord stapled across the finished surface of a building to conduct electricity is so outrageously dangerous. But somehow these people are all over the place. People have a cuz, they got an uncle. Like, I don't know who's out there doing this, but I'm taking out lamp cord all the time. You have to stop. So people are utilizing electrical tape, and they think because of the stretchy nature of it and characteristic that it's going to maintain a sound and permanent electrical connection. Not so, people. You got to take off that electrical tape. Do you know what handymen do? Handymen might, at the very best, use an electrical connect. They won't pre-twist their conductors to get a good physical seat, but they might use a wire terminator, and for good measure, you know what else they'll do? They'll pull out the electrical tape. This is so beyond me. I don't know why people do this. First glance, If you see a wire connector and then you see some little accessory electrical tape around that wire connector, like this, you know, y'all, you got a handyman on your hands. Electricians don't do this. This right here is the number one. All this like accessory electrical tape you find all over the place, this is the number one DIY mistake. Electricians don't actually use much, if any, electrical tape for permanent installations. I'll tell you the one thing that electrical tape is used for in a permanent installation by a qualified electrician is this. It is for labeling conductors in interior and controlled environments. You might open up an electrical panel and find 3 neat wraps of electrical tape just like this to indicate that this hot conductor is a phase or leg of a 277 480 volt circuit. It's for labeling purposes only. There's not enough physical strength or lasting durability in electrical tape to permanently perform any other service. In our next video, we're going to explore the practical application of wire types and sizes and their uses in building construction. Don't forget to like and subscribe.